Welcome to my presentation. In this presentation, let us look at some application problems related to vector operations in two dimensions. In this example, let us say we have a equilateral triangle, and if v is a vector and w is a vector, and those are the sides of an equilateral triangle with area 25 square root of 3, we want to find v vector v dot vector w. Let me write this here. If vectors v and w are the sides of an equilateral triangle with area equal to 25 square root of 3, what we need to do here is we want to find the value of vector v dot vector w. Okay, so first things first, step number 1, let us draw an equilateral triangle, and in here, if I were to say this is the y-axis or the j-axis, and this is the x-axis or the y-axis, and if I were to also drop a perpendicular here, for one of the properties of equilateral triangle are all the three measures of the angles are going to be equal to 60 degrees, 60 degrees, 60 degrees, and one of the rules of any triangle is the sum of the three angles of a triangle should together equal to 180 degrees, and this satisfies that. For an equilateral triangle, all the three corners will have exactly the same measure, which is 60 degrees. If the sides of these equilateral triangles are 2b, if I call this as 2b, this will be 2b, and this side will also be 2b. And therefore, since I have partitioned this, therefore this will be b, this side will be b, and this side will be b, isn't it? So if this whole thing, if this a to b is 2b, then a to c will be b, and c to b will be b. And if this is b and this side is 2b, then the vertical is going to be equal to square root of 3b, coming in from Pythagorean theorem, using the Pythagorean theorem. How do we do that? If this is the right triangle, and if this side is 1, and if this side is 2, this side is going to be equal to square root of 3. That is how we're going to do this. So c squared is equal to a squared plus b squared. We are using that to figure this one out, and therefore we were able to do that. So the height is going to be equal to square root of 3b. Now we know that the area of a triangle is given to us as 1/2 times the base times the height. Since the base here is 2b and the height here is square root of 3b, and since the area is given to us as 25 square root of 3, we'll put that information in there, and therefore when we simplify this, it simplifies as follows, isn't it? So this 2 in the denominator, this 2 in the denominator cancels out, and then we have 25 square root of 3 is equal to b times b is b squared, and then we have a square root of 3 there. Since we have square root of 3's on both sides, if we divide by square root of 3, the square root of 3's cancel out, leaving us with 25 is equal to b squared. Therefore, the value of b is going to be equal to 5. The value of b is going to be equal to 5. Since the value of b is equal to 5, Therefore, the value of 2b is going to be equal to 10, twice of that. The value of this is going to be 10. The value of this is going to be equal to 10. So therefore, each side of an equilateral triangle is going to be equal to 10 units, right? Therefore, from here, we can now write this as, if we let v as a vector, then that is, one side is going to be equal to 10i, and the other side, if we call that as vector w, that is going to be equal to 10 times cosine 60 degrees I plus sine 60 degrees j, right? Therefore, what we need to do now is find the dot product between these two. So vector v dot vector w, we want to know what the product of that is. So that is going to be 10i dot, this is the dot, cosine 60 degrees I plus sine 60 degrees j. Therefore, when we simplify this, this is going to be 10 I times cosine 60 degrees I plus 10i times sine 60 degrees j. Since we know that I dot I is equal to 1, and let me write this a little bit more clear. Since we know that I dot I is equal to 1 and I dot j or j dot I equals to 0, therefore we're going to use that information, and then this goes to 0, and therefore this becomes 10 cosine 60 degrees. 10 cosine 60 degrees. Therefore, we can write this one as, this should be, there is a 10 in front of this, 10 times, this should be, this is a, there is a 10 here, 10 cosine 60 degrees, 10 sine 60 degrees. There should be a 10 here, 10 cosine 60 degrees, and there is a 10 outside of this. So therefore, so 10 times 10 is going to be equal to 100 cosine 60 degrees. Therefore, 100 cosine 60 degrees is equal to 0.5 or 1/2. So therefore, 100 times 1/2 is going to be equal to 50. So therefore, vector v dot vector w is going to be equal to 50. So this is the way we can use vector operations in 2 dimensions to be able to solve some application problems. In my next presentation, we should look at some more examples related to applications of vector operations in 2 dimensions.